Welcome back. So the last video we had it doing a countdown where it would flash the lights and then the robot began to move. This video I want to actually tie in yet another external function because we're going to just keep building on to this. And very shortly we're going to work on the ping sensor and line followers. But it would be nice to be able to use the photoresistors that we put on there a long time ago and have our robot respond to light. So for example, I could make it write a program called Dancing in the Dark, which we might do here at the end, where the robot actually waits until the lights go out and then suddenly it begins to move and it flashes its light. It does all kinds of cool synchrony. May sort of seem sort of silly when you're by yourself, but it actually is kind of cool when you have a group of robots and they're all synchronized to dance to the same beat, and then when the lights go off they all turn on their bright LED lights and start flashing and moving, and it kind of looks like an episode from Swan Lake play or something. But the other reason is it's nice to have an on-off switch. Okay, so for example, these two photoresistors that we still have plopped on top of our board, I'm actually going to do something where the robot is on and it's just waiting, and when I put my finger on the photoresistor and block the light, that essentially turns it on. Okay, so we can have an on-off switch, which is really easy to do. But let's do one little bit of house cleaning first. I'm going to jump back to this page here. Recall that all of these pins here, starting from the second one on the bottom all the way up to the fourth one on the top on the right side as reference to this, are all analog input capable ports. Okay, we can take data in analog, thus the A0 through A9. And because I have several things I want to do, I looking at my board, I can't even remember the video per se, but I have my two photoresistors plugged into like A0, it looks like, and someplace up here on A9. Maybe is where we left it. I don't know. I should go look in code, but that's where mine is. And what I want to do is I want to kind of clean that up. I'd like to have these two photoresistors right here at A0 and A1, and I'm going to zoom in here so we can take a look at that. Okay, so if we look at it this way, you can see that this, I should have my glasses, hold on one moment. Okay, this pin right here is A0, this pin right here is A1. Recall that to get this to work, we have to feed electrons into A0 and A1. We use these 10K resistors to bring it off the positive bus and put it into these two pins. So if the photoresistors are pulled out, which I'm going to do for the moment, okay, right now I've got essentially an unrestricted flow of electrons passing through this resistor going straight into A0 and A9. Alright, so those two pins are high. They're getting all the electrons that can possibly squeeze through the resistor. The resistor is basically there to protect the pin from just getting burned out, but as many electrons as can are going right there. Those two pins are high. If I pull these resistors out, like so, okay, they're actually called floating. All right, so right now there's nothing going in, nothing going out. They're not grounded and they're not high. What I want to do is I want to clean this board up, like I said. So I'm going to take these two resistors. This one's already, I should lay that down so you can see it, already trimmed to a nice length. I'm going to take this resistor and plug it in here so that, get that kind of lined up there. It goes straight into the positive bus and straight into this pin, and it lays nice and flat. I'm going to take this longer one and trim it so it also lays nice and flat. Alright, I'm actually going to go in slightly sideways fact is, I will do that on both of these because I kind of want it to be in the very first hole. Okay. In fact, let's just do that with this one while I'm doing it. There we go. Okay, so you can see that currently these two resistors are going straight from the positive bus into A0 and A1. I'm actually not going to trim these photoresistors yet because we might do something else with them. The photoresistors go back into their positions where one pin goes into ground and one pin goes into the pin A0. This photoresistor, one pin goes into A1 and the other one goes into ground. Okay, so now those electrons have a choice. The ones that are coming up through the resistor, they have a choice. They can either fly up through the resistor and go straight into the pin, or if the resistance is low, they can take an easier path and go up through the photoresistor and into ground. Okay? If I increase the resistance, more of the electrons go to the pin, and if I decrease the resistance, more of the electrons go this way and avoid the pin and go straight to ground. The electrons are always going to take the path of least resistance. Okay? So now you see I've kind of rewired this into A0 and A1. Let's zoom back out so we can of course see the whole robot. And let's look at our code. This is where we left off in the last video. Okay. What we need to do now is we need to add a couple little pieces of code to it so that we can actually see the data. Let's add a couple more constants. Constant integer. We're going to define those two pins. Let's make it, I don't know, let's make it left photo. And we're going to have that hooked up to A0. And this is going to be the pin the left photo resistor is connected to. Alright. And we are going to have the right photo. Okay, that looks good, right? We've got those two pins defined. The next thing we should probably do is give ourselves a little bit of a variable to stuff the data in that we collect from those two A0 and A1 analog ports. So let's make an integer. We'll make a couple of them. Let's make it, let's just make it left value. And I don't know if I've done this yet. You know, you actually can, you don't have to create a separate line for every single variable. You can just separate them with a comma. And, oh, you know, we'll deal with that later. I'll show you that one. And this is going to be the variable to store photoresistor values. Oh, looks like I misspelled variable there. And we'll make a right value. Variable. You know, I'll check my spelling later. Okay. So we've got the left photo and the left value. Let's go down here to setup. Well, let's actually go all the way down to the loop. And since we're going to play, we don't want to sit there and wait for my silly robot all the time. Let's give ourselves a couple spaces and we'll block out this chunk of code. I'm going to put a /* as the beginning of a block out, and I'm going to put a star /* as the end of a block out. So right now all this huge block right here is all commented out. Okay, I'll come and fix that later too. Let's do this because we don't have much time. These videos go really quick. So our two variables were left value and right value. Okay. Left value is equal to analog read of the left, what did I call it? Left and right photo. Okay, let's close that up. And this is going to be collect data into the collect data from the left photoresistor. Okay. And this is going to be the right photoresistor. And oh, look at that, it is a photo. There we go, change that. And that's right photo. And we have the right value. Okay, that looks pretty good. It should work. I think we need to see it before we make any decisions, and then we'll do something with it. So let's do a serial print, and let's put the how do we want to do it? We'll say we'll give it something kind of cool. You guys should be getting familiar with this. We'll do left value is equal to those quotes in there. Left value is equal to, gosh darn it, I'm just stumbling everywhere today. Okay, and Control C, we're going to copy that. Okay, make a few copies of this. What is it going to be equal to? It's going to be equal to left value. And then let's make this the right value is equal to, and then we'll put in the value of the right value. Okay, and what else we want to do? We definitely want to have this on a new line, and why don't we put both of these on a new line? Okay, and we can make that capital. And at the very end down here, let's do a serial dot print new line, and then we're just going to throw in an empty space. And let's put in a delay of 500 milliseconds, or about 1/2 of a second. Okay, and since we're already at 13 minutes, let's take a quick look, make sure we don't have problems. In this case, I'm just checking it. And now I'm going to load it up. Looks like it's loading. Do you notice the lights are still flashing? And what should be happening now is if we hit Control-Shift-M, or to go to Tools, we need to open up the serial window. And we are now getting values, about 230. Let's put my finger on top of this one, 700. And I'm going to put it on top of this one, 700. So it looks like on this next video, if we just put an if-then statement or a while statement, we can make this thing turn on and off by just putting our finger on one or the other photoresistor. Okay? So hopefully I will see you again shortly, and we will move on.